So in this video, all we're going to do is take what we did in the previous two videos and kind of put it all together and graph sine and cosine functions that have been horizontally and vertically stretched or compressed at the same time. So we'll just jump right into an example problem. So suppose we have the function f of t equals 5/2 sine of 3t. There's no horizontal or vertical translations. We haven't dealt with that yet, and we'll do that in a future topic. So the only thing that's going to happen, this 5/2 is going to stretch vertically our function, and this 3 times t is going to cause a compression of our function. But again, it's just a matter of focusing on the toolbox function. So set up your input-output axes. So here's my outputs, and then I have an input axis, and it looks like this is going to be a t-axis. And then graph what the sine function should look like. So we know that the sine function starts at the origin, it goes up to its high point, it comes back down to the t-axis, it crosses the t-axis to its lowest point, and then comes back to the t-axis where it starts all over again. And what we're going to do is just label in our spots, and we don't do any of the labeling until after we've graphed what the basic function looks like. The amplitude of this function is 5/2, right? The toolbox function goes from -1 to 1 for its outputs, but we're multiplying the outputs generated by the sine function. We're multiplying those by 5/2. So this function, sine of 5/2 sine of 3t, is going to go from a low of -5/2 to a high of 5/2. We just distribute this into the interval. So I could come over here and say, hey, the amplitude, the distance above the t-axis, is 5/2. And then this is going to be -5/2. We have the distance below the positive t-axis also 5/2 units. And then I can focus on how to put my tick marks in on the horizontal axis. And again, I take the 3t, and I recognize that this is one period of the graph. And one period happens in 360 degrees or 2 pi radians, and I need to decide whether I'm going to model this from a degree perspective or a radian perspective. So let's suppose that we're going to model from a degree perspective in this case. So then I ask the question, 3 times t, when does that equal 360 degrees? And solve for t. Divide both sides by 3. I know that other places will give formulas for this, but I like thinking it through in this way. I think it helps us to understand what's going on. So 3 goes in here 120 times. So when t is 120 degrees, so we're going to plug 120 degrees in, we get 360, which is one full revolution around the unit circle. So this tick mark is going to be 120 degrees, or just 120. And then we recognize that the one period of the sine function is broken into force. So we take 120 degrees and we divide it into force. And we see that 4 goes in there 30 times. So this should be 30 times 1, 30 times 2, 30 times 3, and 30 times 4. And there's the graph of f of t. So we'll do one more example where we put things together. So here I have a cosine function with a multiplier on both the outside and the inside. And what I want to recognize is that there's a negative sign on this scalar, which is going to cause a reflection in the input axis, which I didn't draw very straight. So we'll try drawing it again to see if we can get a little bit better. So here's the t, here's the output f of t. Cosine function usually starts high, goes low, comes back to where it began, but this negative sign is going to reflect it through the t-axis. So we want to recognize that we actually need to start at the low point when we do the drawing. And I just killed my t-axis with an untimely blow of the eraser. So instead of starting high, the reflection is going to force us to start low, come to the t-axis, go to our highest point, come back to the t-axis, and end up back where we started. And then that multiplier of 2 means my amplitude is going to be a 2. This is a distance of 2, so it's going to go from -2 to 2. And then I just need to figure out what needs to go here for my tick mark. Let's do this one from a radian perspective. We know that one trip around the unit circle is 2 pi radians. So we need to know, when does 2/3 of a t, when does the input equal 2 pi radians, or 1 revolution? So we'll multiply by 3/2 on both sides, which simplifies to 3 pi. So I know I need to put a 3 pi right here. Notice if we were to plug 3 pi in, what would happen? 3's would cancel. We'd get 2 pi radians, or 1 trip around the unit circle. Oops, I just killed my axis again. That's twice now I've slain my axis. Ooh, that's 3 times I've slain my axis. Try this again. So 3 pi is going to be this right here. And then we recognize that 1 period is broken into fourths. So just take that 3 pi and multiply it by a fourth to get 3 pi over 4. So this is going to be 1 3 pi over 4. 2 times 3 pi over 4. 3 times 3 pi over 4. 4 times 3 pi over 4, which would reduce to 3 pi. And there's the graph of our function.